Welcome to this video today, and I'll be talking about microservices architecture for startups. Well, for many people, they don't believe microservices architecture is good for startups because it takes time to build and it requires more energy, more time, and all of that to build. But for me, I think for a startup that is futuristic, microservices is actually a good architecture to embrace because over time you discover that your system evolves better. You're able to bring more developer easily. You're able to do a lot of things better over time. So the gain is going to outweigh the pain at the moment when in the future. So with that, I'll be introducing a very practical example of microservice architecture to any startup can use. You see how simple it is. Not simple to build, but it makes lives very easy in simplicity that can evolve over time. So we'll look into some of the concerns of building microservices architecture now before we move into the architecture itself, so that it becomes clearer. When we get to the architecture, we're able to see why we made the choices of the technologies we choose, and also the thinking process that necessitates such an architecture in the first place. So the first thing to consider is the security. So let's check out the security for our microservice. So just like any application monolithic as well, we need some form of security in the application. So for our microservices architecture, we need to think of security in a different way because we have many services now, and we can't be authenticating the user for every service they want to call. We need to be able to communicate access between all the services on our system. So that's why we settle for OAuth 2 or OAuth system, whereby we use token-based system. When the client wants to get some data, they come with a token, and with that token, each of the services can give the appropriate data based on the access level of the user. So we'll be using OAuth2 for microservices. So that's the first concern that we'll be considering today. The next one is bloated endpoint. This is actually very easy to see, but it's something that is very important. When we break our monolithic application into many microservices, let's say for example 10 or 15, and we have each of the microservices on different servers or different ports, we don't want to be sending the list of all these servers and ports to every client that needs to call our service. So we need some form of singular endpoint for all of them, so that endpoint serves as the entry point to our system, and we find a way to route the request within the system to the appropriate service. So the solution to that is in the next slide. So to solve the problem of the bloated endpoint, what we need to do is to have a router or a reverse proxy that will give us a singular endpoint for all our clients and be able to route requests to different microservices based on a certain part of the URL. So when request comes to the router, the router checks the URL, picks a unique part of the URL, and uses it to locate the service appropriate for that request. For example, an account service is being called, but from a singular endpoint, the router is able to pick account from the endpoint from the URL and call the appropriate microservice to serve the request. So that's what we need to do to solve the problem of bloated endpoint. So in our architecture, at the end of the day, we'll see how to implement such a router to do the job perfectly well. But here's another thing. With the router comes another problem, because how does the router maintain the list of all the services we have and the list of all the instances of each service? Because one service can have multiple instances to load balance on. So that becomes cumbersome to leave to the router. There is another solution we need to solve that particular problem now. So let's check it. So on the routing section, we saw a couple of problems that come with routing, because we need a way to be able to locate each of the services on our system by the router, and the router has to use just the unique name that is found in the URL. The router doesn't have access to the IP and port of each of the services, because that will not be a good design for us to have within the router the IP and port. So when things change, how would the router know that this particular service has been moved away from this IP? So that introduces another level of complexity, which is service discovery. We need to be able to discover all services by name. So we have another service that does that for us, that has the registry. It's also called service registry. The registry, the location of all the services we have on the platform and their current location, the unique name and their current location. We have this service name and the service location per time. Also, this service registry is able to keep track of how many instances this particular service has, because it's possible that one service has multiple instances per time, maybe running on different ports and on the same server on different ports or different servers sometimes. So the service registry is able to keep track of all the services we have by a unique name and their location on the system. And when the router calls for this particular service, the service registry looks it up and gives to the router for the eventual routing of the request. So beyond being able to be the registry where all the microservices on our platform registers themselves, the service discovery or the service registry also needs to be a health checker. It needs to be able to check the health of every microservice registered within its registry. Also, it needs to be able to support multi-node. Multi-node meaning multiple instances of a particular service. So we have one service called account service that has registered itself with the registry, but we have multiple instances of that service on different ports. So the service registry needs to be able to maintain the list of these services by a singular name and check the health of all the instances and be able to decommission anyone that is not LD. For the ones that are LD, keep them together and periodically check this health for all the microservices and all the instances of each of the microservices that we have. So that's one of the jobs that our service discovery needs to do. The next one is load balancing, because like I said, each of the microservices can have multiple nodes, can have multiple instances, and the service discovery needs to be able to return the location of this service based on some certain algorithms that will enable it to distribute requests to all the instances like evenly. If a request comes for account service, for example, and an account service has 3 instances available, the service discovery should be able to load balance between all the 3 instances of the same service that are available. So that's one of the jobs that the service discovery needs to be able to do perfectly. So one very important concern we have when we are building our microservices architecture is logging and error tracing. We mentioned earlier that we have a service registry where we have all these microservices listed. We also have multiple instances of these microservices. So for example, let's say we have 15 microservices. Each of the microservices we're launching like 3 instances of each of them. If that's about 45 nodes. Errors can be generated from any of the nodes depending on which one is serving the request per time. If there is a bug or there's an error to be traced, we don't want to be opening all the 45 instances of this application to check the error and examine the log. We need a centralized logging system where we can easily go through and find bugs and find error. So that's one other concern we have in microservices. We will check out this concern when we get to the real architecture of our microservices. So the next one is dynamic configuration parameters. When we have multiple instances of an application and we have multiple microservices or multiple applications like up to 10 or 15, we need a way to maintain the configuration parameters used by each of the microservices and each of the instances in a centralized way. For example, the database URL and port and username and password used by the applications should not be within the bundled applications themselves, because we have multiple instances and we may want to change things on the fly. Also, for security reasons, we may not want to expose the password to the database to every developer. So we have this centralized configuration service that supplies each of our services the configuration parameters on the fly. So with that, we're able to externalize these parameters and we can change them on the fly and update the services as it goes on. So this is a very good one. That's one other concern we have for microservices. And we can also version control the parameters when we make changes, and we use Git version control. We can also maintain different versions of these configuration parameter files instead of having them inside each of the apps. So it's a good one that we need to consider when we are implementing our microservices. Don't worry, when we get to the real architecture, you will see the way it works together. So the next thing we need to talk about is the session or caching management system. So we have multiple instances of each of our microservices. We also have many microservices that may want to speed up data. So for example, let's pick a microservice that has multiple instances and it's trying to speed up data delivery to the client. Maybe this particular data has so many demands at the moment and it's trying to cache the data and send it to the client. Because of course, it is not advisable to have session in microservices architecture. You're supposed to be stateless as possible, but sometimes business requirement may demand you have a little session or a caching system where you cache some data. If you have such a need, you want to externalize this caching system or this session system in order that all the instances of the microservices can access this thing outside of themselves. So this makes it cool that in order to speed up data, you are not building so many redundant data across different instances. So session management being centralized is very, very important in microservices architecture. So here's the real architecture that we've been talking about. We've already talked about each of the modules here in the previous slides. So let me just brush through this once again and point out a bunch of the things we've talked about. We have the mobile and the web clients who are trying to get access to these microservices within our system, but they do not have direct access to these people, to these microservices. They need to get through the router, and the router uses the unique name, which is part of the URL, to locate the appropriate microservices. Don't forget, the router needs to call the service registry first to get the location of each of the microservices we have. We have the centralized logs, like I mentioned. It makes it easy for us to trace bugs. We have the session management, or caching management, where we cache data that we need for faster delivery, and each of these microservices have access to this service. Then we have the OAuth2 server. When the client is coming and he doesn't have access token, we need to redirect the client to the OAuth server. So that's pretty much what it is, and these are our microservices that are for business logic that we have. So that is what it is for now. So in the next couple of videos, we'll be looking at all the infrastructure microservices. Like we saw here, all these are infrastructure microservices. This configuration server, router, OAuth2, session, centralized logs, and service registry, they are not part of our business logic. They are just for the infrastructure, and without them, the system cannot work. At least cannot work properly. So I call them infrastructure microservices or default microservices. So what is next is for us to implement each of them and get to see how they work together to make our entire architecture work better. So thank you very much for watching, and leave a comment, and if there's anything you feel is not right or not appropriate, just tell me, and see you in the next video.